All right, so we're going to take a look at a review for characteristics. And because this is a review, I will not be writing the notes for you. You're going to write the notes in your own words. So I'll show you how to do it. Then you can go ahead and write down the notes that you need so that you know how to do it. All right, so I'll do example 2, and then you will do example 1. I'm just going to make this full screen. Okay. So yeah, I'll do example 2, you'll do example 1, and then you'll write notes to yourself right here. All right, so what is domain? Remember, domain is from left to right, so that would be a good note to write. So it's the x-axis from left to right. So looking at the left right here, okay, is there a graph right here? Yes, there is. Now, I could say my domain is -5, but that would be incorrect. Why? Because there's an arrow meaning that it's going like this forever. So if it's this way, it's going to where? -infinity. So we're going to start off with -infinity. And because it's -infinity, it's open. And then on this side, let's see, where is it going? So on this side, it's going forever up this way, right? Which again is going to +infinity. All right. Another way we can write that is all real numbers. Okay. So my domain is from -infinity, from left to right, everywhere there's a graph. Okay. So go ahead and write down, how would you know how to find domain for you? All right, for range, remember range is your y-axis from the bottom to the top. Now be careful with exponential functions because exponential functions have isotopes, right? What is an isotope? Isotope is a line that this exponential function approaches but never reaches, okay? So it gets very close to, but it does not reach. I know it looks like it touches it, but it doesn't. All right, so because it doesn't reach this, the bottom of my graph is going to be -3. And because it does not touch it, it's going to be open. And then the top of my graph, so here's my top. It's not just 5, but there's an arrow going on forever. So infinity. And again, it's open because that's infinity. And while I'm here, you could write it in the other notation. X is greater than, not equal because it doesn't touch it, negative. Sorry, did I say X? Y'all, I'm tripping. Y, because it is range, is greater than -3. Domain here, you could say X is in between -infinity to infinity. Now you have your range. Please go ahead and write down your definition for range. Do you want to keep y-axis bottom to top? What is it that you need to tell yourself? Okay. All right. X-intercept. Where does it cross the x-axis? So it crosses the x-axis right here. So this is around, if this is 2, that's 1. So let's call it 1.5. So I'm going to write it in coordinates. 1.5, x goes first, comma, y, 0. All right, again, write down your notes. How do I know what is the x-intercept? All right, for the y-intercept, where does it cross the y-axis? So here's the y-axis. The y-axis, it crosses at -2. So again, x and then y, so 0, -2. Once again, in your notes, please go and write notes to yourself. Okay, how do you know what the y-intercept is? All right, then for increasing and decreasing, so increasing is when is the graph going up? So you can see, what is the graph doing? It's going up the entire time. So we're going to say from -infinity to infinity, it is increasing. So when is the graph going up? Decreasing would be, when is it going down? So if you had something doing this, that would be going down. But here, this graph is never going down. So this is NA. Once again, please go ahead and write the definitions for both increasing and decreasing. And by the way, when you're writing increasing and decreasing, even though you're looking at what is happening on the y, so you see the y is going up, you're writing your answers in terms of x. So from -infinity to +infinity, the graph is going up. You see how I said that? From -infinity on the x to +infinity on the x, the graph is going up. Okay. All right, positive and negative. All right, this one is one that you guys sometimes get a little confused on. Positive and negative is in regards to the x-axis. All right, is the graph positive above the line? All right, so right here, it's above the line right there. All right, is it negative below the line? Okay, so below my highlight right there. So this graph is both positive and negative. So how do I write that? Again, I write it in terms of x. This was 1.5. So to the right of 1.5, it's green positive. Okay, so how do I write that here? I say to the right. And again, if you look on the right hand side of the x-axis, that will give you the arrow. It is greater than 1.5. It's positive. The blue line is to the left. And if you look at the arrow there, that will tell you the arrow. To the left of 1.5, it is negative. All right, so that's positive and negative. All right, question being, so please go ahead and write your definitions for positive and negative. All right, end behavior, what's happening at the ends of the graph. So let's just look right here real quick. All right, so if I look here at the end and here at the end, okay? On the left-hand side, x is going to negative infinity. So you see where it says x is going to negative infinity. This is the left side. As x is going to positive infinity, this is the right side. Oh, and here I'm writing notes and you're supposed to. But anyway, what's happening on the y when x is on the left? So right here on the y, what's happening? This graph is coming very, very close to this line, but does it ever touch it? No. So instead of it going beyond like all the way down here, it just approaches this line right here, which is -3. So f of x is going towards -3. It does not cross it. On the right-hand side, what's it doing here? So here it has no restrictions. It just keeps going up and up and up and up and up forever. So that one's going to infinity. So be careful with end behavior with exponential functions. It's not infinity and negative infinity anymore. Because of an isotope somewhere, it has a restriction where it cannot pass. All right, so please go write your notes for end behavior. All right. Finally, average rate of change, and we're going to go ahead and put average rate of change for both of these questions. So this one will be 0 to 1, and the one that you guys are going to end up doing is going to be 2 to 3. Okay, so this is average rate of change. I'm going to do average rate of change from a graph, so this one right here, but you're going to write notes for yourself on how do you do it from a table and from an equation. So from a graph, all right, you're going to start with your formula. Right, so y2 minus y1 over x2 minus x1. All right, y2 minus y1 over x2 minus x1. So parentheses minus parentheses over parentheses minus parentheses. Now, the reason I put this parentheses, as you know, is you guys like to sometimes omit the negative, so we're not going to do that. Want to make sure this is typed in correctly. Whenever they give you the interval, it's always your first one is x1, your second one is x2. So all we have to do is replace it. In the bottom, x2 is first, so that's 1. And on the bottom right here, x1, which is 0. Now on the graph, you just need to find where x is 1, what's y? When x is 0, what's y? So looking on my graph, when x is 1. All right, so when x is 1 right here, y is -1. So y is -1. When x is 0, so when x is 0, y is -2. And that's how you find your others. Then you're just going to put that right up in the calculator. All right, press divide first before you type everything in. Parentheses minus parentheses over parentheses minus parentheses. Let's go ahead and put in our numbers. On the bottom, we had 1 and 0. On the top, we had -1 and -2. And boom, my answer is 1. So that's how you do average rate of change, okay, from a graph. It's not much different from a table because it's right in front of you. From an equation, you type it into Desmos, hit gear, make it a table, and then it's the same thing. So you should have all of this written down. Please go ahead and complete example 1. Let's practice.